HeliPilotGh. So helicopters don't just rely on the main rotor. The tail rotor is also critical for control. But what happens if it stops? If it stops doing its job, what do you do? Even when it is not broken. So that's what we call LTE, the loss of tail rotor effectiveness. So let me break it down. So what is LTE? LTE happens when the tail rotor cannot produce enough thrust to counteract the torque of the main rotor. So even though the tail rotor is still working, if it's certain wind conditions can make it lose its effectiveness and causing the helicopter to spin uncontrollably in certain videos you've sent to me. So how does this happen? So winds from certain directions can disrupt the tail rotor over airflow. And another way that this can happen is when you have high power settings that can increase the torque demand. Mostly downwind is possible. Or hovering or slow flights, making the helicopter more vulnerable. So let's see. Imagine trying to paddle a canoe, but the water suddenly swells against you. No matter how hard you paddle, you can't keep it straight. That's what tail rotor looks like, or that's what the tail rotor faces. So there are critical wind directions for rotor helicopters that are critical, So there's one we call the main rotor disc interference. That's when the main rotor downwards disrupts the tail rotor. There's also the tail rotor vortex, when turbulent air flows into the tail rotor. There's what we call weather cocking, when the helicopter tries to turn itself into wind, There's also the high power and the low airspeed, where the tail rotor demands excess capacity, And some of these things like I said, the same thing could be a sudden yaw, uncommanded yaw, and you see that your tail rotor may feel weak, like not effective. And then also, it could also be that the yaw rate will increase drastically. You are not supposed to be able to move it too much. What pilots will do will be to avoid the tailwind, mostly tailwind hovers. And you also try to stick your nose into the wind and you maintain adequate airspeed if you are not doing a slow flight. If you are doing a slow flight, you must be cautious, especially if you're having high power settings and you are flying heavy hot conditions. Density altitude high. You also have to stay ahead of the machine. When this thing happens, recovery is very difficult. In the simulator, you may, but in real life, you have to immediately apply what we call forward cycling to gain speed. You can lower collective to reduce the torque, to reduce the spin, and also you avoid full pedal. If altitude permits, you can do what you call auto rotation, where you control the aircraft to the ground. So tail rotor, it's not really about mechanical failure alone. Aerodynamics and the wind conditions can affect it. Also, awareness of your machine. How well you know your machine can also affect it. Cheers, HeliPilotGh.